Standard position is when we sketch angles called rotational angles on the Cartesian plane, the xy axis, with the initial arm where the angle starts as the positive x-axis. These angles can be positive if you move counterclockwise, which is all we did last year. For the most part, is you moved counterclockwise from the x-axis and did positives. Okay? So we're going to look at a positive rotational angle. Now, this is what I suggest. If you do this, not that, if you do this, it will go better. So we're going to draw ourselves pretending that that's straight. That is not. A Cartesian plane. Okay? Honestly, trig's my favorite unit. It really is. And you guys understand the unit circle better. When you understand the unit circle better, the unit circle questions are not hard. Trust me. It's if you don't understand it that they're hard. Once you understand where you're getting stuff from, it's easy. Okay? Now, let's make sense. So through trig, what my biggest thing that I try and do is if we understand, we will do better. If we memorizing scares me, like I've said to you before. You're a little stressed and memorizing stuff falls out of your head, right? We don't want that. We want you to understand so no matter how much stress you get, it can't fall out because you know it. So we always start on the positive x-axis. Something is... I'm either hearing things or someone's phone is vibrating right now. Well, stop now. It's okay. I'm fine. Did you? Okay. This is why Amy and I are friends. The rest of the class is like now just thinks you're crazy. There was like a vibrating. Yes. Okay. Okay. That's fine. BFF. All right. So we start here at 0. And then we draw a box, right? We did this in grade 10. It was crazy. It meant 90 degrees. Yes, you did. Okay, well, whatever. You're there. We got you. Okay. So we do this. Watch. What does that mean? What do you think this arm is then? 90. Wowzers. You also just put this on your unit circle yesterday, so we're hoping you're still there. Okay. Then we go this way. Boom, boom. Another 90. So what's this? 180. Boom, boom. Another 90, so 270. Boom, boom. Another 90, so 360. And then last year we stopped there. Most often, some people taught more, some people taught less. Doesn't really matter, but that was the basic curriculum we had to cover. The 0 to 360. All depended on when it hit. If it hit when we were online or not. Sometimes you just got there what the curriculum was. Okay? So 0 to 360. But it's not rocket science. We can just keep going. If we add 90 to 360, we get to 450. Add 90 to that, we get 5, and add 90, add 90, add 90, add 90. We could just keep going, right? Go on for life. We would just keep rotating, rotating, rotating. We agree? Now to draw a positive angle, it is 100% doing it right now.
Is it your phone? Does it sound like it's over there?
No. I feel like I'm losing my mind.
No, I heard it that time.
You heard it that time? Okay, thank you. Okay, whatever, I don't even care. I'm just glad I'm not losing my mind. So, standard position angles. We draw a dot at 0, 0, because that's where we're always going to be rotating about. That's our little, like, remember when you were in elementary school or wherever, and they give you like a pie chart or like a pie pinwheel, and they could put like a metal thing in it, and you could just go like this, and it would fling around?
No.
That's the unit circle. Just flinging around. But if you like flick it and then it goes counterclockwise, it would be doing a standard position angle. Okay? Standard position angle is a positive angle between 0 and 360. Now, so there's the little like gold thing that you could push through, and then you push the little things, and then you don't know what I'm talking about?
No.
Well, yeah, I think that's like your description's little.
It's awesome,
Okay.
James.
You want to draw one for us?
No.
Draw it.
So there's the little gold thing it spins on, right? Now, your initial arm at all times, it does not matter if you're drawing positive angles or negative angles. Your initial arm will sit on the x-axis. So we draw ourselves a little arm with a little arrow. So there's a little arrow. That's the initial. Okay? Your final arm ends where the heck the angle is. So we're going to draw 135 degrees because that's a positive rotational angle. So what do? I start here, and I go to 90, and then how many more? 45. What do these cut in half to? 45. So the arm's actually going right up the middle. Now everyone's hearing this noise. If not, you guys need ears.
I think it's a humming fan.
No.
That is definitely not a humming.
That is a vibrating phone. Okay. Do you see how I drew an arrow? Do you see how I start on the x-axis and I draw an arrow to the terminating arm? Do you see how it's showing that? It is going counterclockwise, and I have to draw the arrow because if I don't draw the arrow, I could also be finding this one. Don't draw this on here. It will look really, you won't know what the heck you're doing. I could draw the arrow this way, and clockwise it's negative. So this would be 0 to 90 to 180 to 225. This would be negative 225. That's what that would be. So you have to draw the arrow to show that you're going counterclockwise and it's a positive angle. So I label it as 135. Okay. Negative rotational angles just go clockwise. You still start on the x-axis, but now you're going to label them better. So you're going to go 0, negative 90, negative 180, bless you, negative 270, negative 360. And I want you to draw negative 225. So I still have the rotation in the middle. I still have my initial arm on the x-axis. That will never change. If your initial arm is anywhere else, you are wrong. You might be like, but what it? No, in 30, you are wrong. It has to start on the x-axis positive. Now we follow ourselves around, but we're going to go clockwise this time. So this gets me to 90. This gets me to 180, negative 180. And then how much more do I need to go? Halfway. I need to go 45 more. So I'm going to draw my halfway. Boom. And then I can label this negative 225. Do you see that they actually terminate on the same arm? They're terminating in the exact same position. These are actually what you're going to learn. You're going to learn they're called coterminal angles. Coterminal angles terminate on the same arm. They're coterminal with each other. So if you go onto the unit circle, they would land on the same spot. They're both landing on the 45-degree angle in quadrant 2. Are they not? Remember that 45 we drew yesterday in quadrant 2? They're both landing there. These are both terminating on the exact same arm. So if I asked, go pull out your unit circle for a second. If I asked you, paying attention now, we're getting a little ahead of ourselves, but because we can do it. If I ask you for cos of 135 degrees in an exact value, because you understand your unit circle, you go to 135, which is where this one's drawn. And the answers are always in what? What did I tell you to memorize? Calgary, Stampede. So I want the what? The x value, right? So what's the x value at 135? Negative root 2 over 2. Boom, I have my answer. What if I ask for the exact value of cos negative 225? What's its answer going to be? Where does cos 225 land on? The exact same arm, correct? And I want the x value of it. Wait, what is it? Oh, we found it already. It's negative root 2 over 2. These are terminate on the same arm, so their answers will be the same. Get what I'm saying? Coterminal. And whenever you're given an angle, the answer's on the outside of the unit circle. When you're given an answer, you're looking for the angle on the inside of the unit circle. Okay? All right. So the terminal arm is where the angle ends, and it can be in any quadrant or any axis. Like if I did 270 degrees, you would draw it and it would land on the negative y. Okay. We did this already. I want you to do this. Sketch these. 40, 140, negative 240, and 340. So sketch 40 degrees. So we're going to label it 0, 90, 180, 270, 360. 40 degrees is less than halfway. So 45 is right at the middle. It's a little bit less. I think a binder's kind of heavy. I'll just look. I'll see if I can find one. Okay, 140. We have 0, 90, 180, 270, 360. We're drawing 140. So we start here. We go past 90, and then we need to go another 50. So a little past half. That's all. Arrow. 140. Try drawing 50. I don't know. It looks kind of like 45. They're not going to like bring out a protractor and see how accurate you are. But if it's like 140 and you're drawing it at like 100, straight up past 90, they're going to be like, come on, do better. You know what I mean? Okay. Negative 240, we have to label 0, negative 90, negative 180, negative 270, negative 360. So I'm going to start here, and then I'm going to do 30 less than 270, so it'll be like here. Negative 240, and then 340. Short of 360, so it's like here, like that. Okay, then we're going to flip over. Okay, we're converting from degrees to radians and radians to degrees. So, remember how I told you how we did it yesterday? We talked about the converting between radians and degrees. That 2 pi is the same as 360. If I do 2 pi over 360, I get pi over 180, so there's that conversion. What you need to remember is degrees to radians, pi on top. So you're going to multiply by pi over 180. What's the fastest way you can do it? Take the degree, divide by 180, math, enter, enter, add a pi. Right? That's the fastest way you can do it. But why is that? So let's try it out. So if we have 315, we're converting from degrees to radians. Degrees to radians, pi on top. So I'm either multiplying by pi over 180 or 180 over pi. Pi on top means the pi is on top. Right? So which one am I going to multiply by? Pi over 180. You're with us. It's fine. We got you. So it would be the same as 315 pi over 180, which is true. But they'll always have the reduced version. So if I put the pi in, no matter how viciously hard you press math, enter, enter, no matter, like, if you step on your calculator on that button and you push it really hard, it's never going to turn to a fraction. You're going to get mad. Because pi is a non-repeating, non-terminating decimal. And non-repeating, non-terminating decimals can't turn to fractions. Okay? So if you're putting it into your calculator, you have to leave the pi out and then put it back in. Right? Add it. So when you put it in, you get 7 over 4. So this is 7 pi over 4. Okay, 70. Try 70 out. Go. Try 70. So I'm going to multiply it by pi over 180. And what is it reduced to? What's 70 divided by 180? 7 over 18? 7 pi over 18.
Oh.
Okay. Now we're going from radians to degrees. Radians, I use Dr. Pot and RD Cobb. Or you can use Dr. Pot and be like the other one's opposite. Those are your options. But radians to degrees, pi on bottom. So we're going to multiply by 180 over pi. In this case, the pi's cancel because they both had a pi on the top and the bottom. So when you type that in, you type in negative 7 over 3 times 180. And what do you get? Negative something. Negative 420 degrees. Don't forget the degree symbol. All right. Negative 1.4 radians. This is different than the previous one because it doesn't have a pi. You see how it doesn't have a pi? They put the pi into it. So they turned it to a decimal, which is totally fine. We're going to go negative 1.4 radians to degrees, pi on bottom, already top. So 180 over pi. So now the pi's don't cancel off. So you're going to have to go negative 1.4 times it by 180, divided by pi, and you're going to get a decimal of some sort in degrees, which is fine. This is true. That is not a false statement. Negative 80.2 degrees. We're skipping past 4 because it doesn't really fit in for now. We're going to come back to it. We're going to flip over. 3 to radians, pi on top.
I've never done this.
Because you need to multiply. I know. Welcome. This is a brand new lesson. I just gave you that knowledge.
We're flipping?
Okay, we're flipping. All right. If I give you guys degrees, easy to sketch, correct? Because you've been taught since you were little what a degree looks like, correct? I just welcomed you to the world of radians yesterday, so you're not that great at them, right? Welcome to the world of radians. Now, the catch is, if you stink at drawing a radian, what could you do so that you could draw it easier? You could convert it to a degree. Radians to degrees, pi on bottom. So you multiply by 1 over 80 over pi. Because the degree and the radian measure are the same once you actually solve for them, correct? So if you convert a radian to a degree, it might be easier for you to draw it. Okay? I don't want coterminals right now. I just want you to sketch all 4 of these. And I don't care how you figure that out. It might be converting the radians to degrees, though. And by might, I mean probably going to happen. Because you just welcome to the wild, wild world of degrees. Oh, there's 6 of them. I want you to draw all 6, please. Try to draw 750. I believe in you. What I'm going to tell you, just in case you did not do this, is if you convert it to degrees, that's totally fine to draw it, but you still have to write the angle as a radian angle, because that's what you drew. And what you need to do as well is label your x and y axis in radians. So just go back and we're going to redo that if you didn't. Awesome, put away your phone. So we have 60 degrees. We're going to go 0, 60, 180, 270. I kind of stopped there. I don't know what happened. And then 360.
Wait, why 60?
There you go.
It's been a 9 the whole time. I have no idea what you're talking about. We're not rolling back the tape. I don't really care. Okay, so we have to draw 60. I got a little excited about 60 drawing. So we start here, rotate about here, and 60 is 30 less than 90. 45 is halfway. Boom, boom. Arrow to it. Make sure you have this arrow 90 degrees because you're showing that it's. Oh, I just did the backwards. I don't even know what's going on right now. 60.
Yeah, we deserve a break.
They're so cool.
No. Okay, so, or grammar juice. So, before we move on, I want to talk about coterminal angles. Coterminal angles terminate on the same arm. We agree? That's what we just discussed. We said negative 225 is the same as 135. We agree? So, let's discuss how they work. If I draw to here, I'm just drawing 60. 60 is coterminal with 60, but do not give that as an answer. It's the same angle, okay? But if I keep going around, I'm going to reach what? 360, and then how much further do I have to go? 60 more. We agree? So then I'm at 420 degrees. So that's one that's coterminal with it, correct? Okay, what could I do again to get another coterminal? Do another loop. And when I do another loop, how much am I adding onto it? 360. And then I could do what again? 360. What if I went reverse? What if I went this way? It would be negative 300, correct? So to get coterminals, all you're doing is you're adding 360s to your standard position, or you're subtracting 360s from it, okay? So here, I have 60, I can add 360, and I get 420. I can take 420, I can add 360, and I get 780. I can take 60, I can subtract 360, and I can get negative 300, What else can I do? Subtract 360 from that, and I get negative 660. All of those will just, because I'm going around a full circle, I'm just going to keep landing on the same spot. Do we agree? Now some people will say, well, if it's an unlimited amount of coterminal angles, how do I know which one's the answer? What happens is on a multiple choice answer, they'll give you one of them that's coterminal. So you'll try and do the other ones, and they won't be 360 away from your original, whether positive or negative. Okay? So I just listed a whole bunch of coterminals. Let's go to 5 pi over 6. Most people are going to convert. Radians to degrees, pi on bottom, right? So when these pi's cancel, what's 180 times 5 divided by 3? It's 300? Yeah. That's the same as 300 degrees. However, it is still radian measure, is it not? Isn't it? So can I just be like, it's 300 degrees now. Write everything in degrees, write it degrees. Did it ask me to draw 300 degrees? No, it asked me to draw 5 pi over 6. You convert it so that you could draw it. So what do I have to do? Label my axes in radians. So this is 0. I don't put a degree symbol because it's radians. 90 is pi over 2. 180 is pi. 270 is 3 pi over 2. And 360 is 2 pi. And I still draw it just like it's 300 to help me. So I start here, go here, and if 60 less than 300, or 60 less than 360, so it's like this. And I label it 5 pi over 3. Now I told you when it was in degrees, we could find coterminals by adding 360 and subtracting 360. We agree? What is 360 in radians? What was 360 in radians? We drew it over there. 2 pi. So what can I do? I can go 5 pi over 3 plus 2 pi. What did I tell you? I told you that if you put the pi's in, no matter how hard you slam your calculator in the math enter, it ain't giving you a fraction, correct? So how could I do it so that it would actually get me a fraction? Yeah, put everything in without the pi's. So go 5 over 3 in brackets plus 2, enter, add a pi. Try it out. Everyone's doing it. 5 over 3 in brackets plus 2. Because really what you can do is you can also get a common denominator of 3, right? So it's adding 6 pi over 3. So it's actually going to be 11 pi over 3. Did everyone get 11 over 3? Same thing. So it's 11 pi over 3. That's one of mine. What if I do 5 pi over 3 minus 2 pi to get another coterminal? So you do 5 over 3 minus 2, which is 5 over 3 minus 6 over 2. So you get negative a third. That's what you're getting? So negative pi over 3. Or negative 1 pi over 3. So do you see what the difference is if you have radians or degrees? You just add 2 pi's, or subtract 2 pi's, or add 360s or subtract 360s. You can convert a radian to degree to draw it, but you're still going to have to keep radians. So negative 2 pi over 3, radians, degrees, pi on bottom. So I'm going to get negative 120. So when I go to draw it, I still have to label properly. 0, negative pi over 2, negative pi, negative 3 pi over 2, 2 pi, negative, sorry. And then I need to get to negative 120. Well, this is 90, so it's 30 more. So it's going to be like here, here. And I label it as negative 2 pi over 3 because that was what was given to me. And how do I get the coterminals? I take it and I add 2 pi. And I add 2 pi and I add 2 pi. Or I subtract 2 pi, subtract 2 pi, subtract 2 pi. And I could get a whole bunch of coterminals. Correct? If you want to use your calculator, though, you can't put in the pi. So 2 pi over 3 plus 2 pi is going to get me 4 pi over 3. I could take 4 pi over 3 and I could add 2 pi. And I get 10 pi over 3. Or I could take the negative 2 pi over 3 and I could subtract 2 pi. And I would get negative 8 pi over 3. So you're literally adding 2 pi's, adding 2 pi's, adding 2 pi's, subtracting 2 pi's, subtracting 2 pi's, subtracting 2 pi's. You know what I mean? What do you mean? You don't know.
Negative 2 pi and 2 pi, and that equals 4 pi, shouldn't it be 0 pi?
You need common denominators. So like if you were actually adding these without your calculator, which I told you you could put it in your calculator, you need a common denominator. So this would have to be 3, right? And I'd have to do it to the top as well. So I would get negative 2 pi plus 6 pi is 4 pi over 3. Or you can type it in your calculator but without the pi's. Like this one would be over 3 as well. So it'd be 4 pi plus 6 pi, which is 10 pi over 3. So you have to be able to sketch these. This is one of the easier things. You have to be able to sketch these. You will be asked to find coterminals on tests. You'll have to use coterminals to find stuff. Okay. Page 175. Yes, you have homework. 1AC to CD, 3 CD.
How many CDs are we getting?
So many CDs, so little time.
Oh, that's a lot of movies.
Yeah. 7.
No CD this time?
No CDs. 8.